Alright guys, so we are going to do some factoring review, and I know for some of you it's been a couple of years since you've done this, so that's why I put together this video to kind of walk you through that process, and hopefully it will refresh your memory. Some of the things that you need to know going into this are you need to know what factors are. You need to be able to recognize combinations of numbers that give you specific outcomes or desired values, and you need to be familiar with the greatest common factor. So if those are things that are unfamiliar to you, I would suggest that you Google that before you start watching this, or that you look up some YouTube videos or something like that. But I'm going to go ahead and get started. I'm going to use these guiding questions. They kind of walk me through the process, and I'm going to show you how to use those to factor a trinomial. Alright, so in the first question, I have a trinomial. Trinomial meaning I have three terms, so a squared, positive a, and negative 90. Those are my three terms. So the first question I'm going to ask myself is, what is a, b, and c? So this is really familiar to us. A is the number with the quadratic term, b is with the linear term, and c is the constant. So when I look at this a squared, I know there's a 1 in front of it. So I know that a is 1. And when I look at the second term of plus a, I also know there's a 1 in front of it. So I know that b is also positive 1. And then my constant is going to be negative 90. Okay, so that's just my first question. What's a, b, and c? So my second question is, what is a times c? So I'm literally going to say a times c is negative 90. And I'm going to make a t-chart. So this number right here came from multiplying a times c. So then I'm also going to write in what b is. And b goes over here. So what goes in this part of the chart is a times c, and b goes here. So what I'm looking for is what are the factors, so I did a times c, what are the factors of a times c? So what are all the ways that I can multiply numbers together and get negative 90? So I could have negative 90 times 1. I could also have positive 90 times negative 1. I could have 2 times 45, and because 90 is negative, one of those will have to be negative. I could also have 2 times negative 45. All right, does 3 go into 90? Yes, it does. So I could have negative 3 times 30, and I could have 3 times negative 30. So what I'm going to do is I'm going to list out all of my factors and know that every number, because the 90 is negative, I could have combinations of either factor, one being negative and one being positive. So I'm going to keep going. Does 4 go into 90? Well, I'm not sure, so I'm going to check my calculator. So I'm just going to say 90 divided by 4, and I get 22.5. So I'm looking for the integers. So 4 is not going to go into it. Will 5 go into it? Yes. So 90 divided by 5, I get 18. And again, 5 times 18 is positive, so one of those is going to have to be negative, and one is going to have to be positive. All right, can 6 go into 90? So 90 divided by 6, I get 15. All right, I'm going to continue my table over here because I've run out of room. All right, so 90 divided by 7, no it can't. 90 divided by 8, I get a decimal. 90 divided by 9 is 10. So I have 9 times 10, and then I have 9 times negative 10. And then my next number after 9 would be 10, but I already have 10 accounted for. So these are all the factors of 90, all the ways that I can get 90 when I multiply two numbers together. So what I'm looking for, after I found the factors of a times c, I'm looking for what factors add to b, and that's why I put my b value over here. So when I take those two factors and I add them together, I'm looking for the one that will give me a positive 1. So negative 90 plus 1 is negative 89. Okay, 90 plus negative 1 is a positive 89. So that's nowhere near that one that I'm looking for. Negative 2 plus 45 is 43. That's not what I'm looking for. 2 plus negative 45 is negative 43. And what you'll notice is that each of these, when I move the negative but I keep the same values, is those, when I add them together, the number's not going to change, it's just a sign. So I'm going to keep going down. I'm not going to waste your time. I know you know how to add. And when I think about a positive 1, I'm looking for a positive and a negative number that are 1 apart. And so when I go down here, I know it's going to be 9 and 10. And I want the 1 to be positive, so I want the 10 to be positive. So I know that negative 9 plus 10 gives me 1. So these are the factors that I'm choosing, negative 9 and 10. So what factors add to be negative 9 and 10? So now I'm going to rewrite my binomial, or I'm sorry, my trinomial. So a squared, and then I'm going to have my minus 90 on the end. But my goal is I'm busting the b. So the b is 1a. So what I'm doing is I'm busting it into 2 terms that still add up to a positive 1. So I found the 2 terms that still add up to a positive 1 are negative 9a plus 10a. So I want to point out what we've just done is we've turned this trinomial into a polynomial, a 4-term piece, because we need 4 terms in order to factor. And so what we've done is we've not changed the value of this trinomial. A squared plus 1a minus 90 is going to be equal to a squared minus 9a plus 10a minus 90, because negative 9a plus 10a still give me that positive 1a. So all I've done is I've taken that b term and I busted it into 2 pieces that are still equal to this original one. Okay? So I have rewritten my my trinomial with a busted b. So I broke that 1a into negative 9a plus 10a. So then my next question is, how can I group the 2 binomials? And this answer will always be the same. I'm going to group them as these 2, and then I'm going to group them as these 2. But be very careful that when you group that second one, that you include this positive sign with the second group. So I'm going to put those parentheses right next to each other. So that's how I've grouped the 2 binomials. All right, question 7. What is the GCF of the 2 binomials? So I'm going to look at each binomial, and I'm going to take out the greatest common factor, and I'm going to divide that out. So when I look at a squared minus 9a, so this coefficient is a 1 right here. So 1 and negative 9 are going to have nothing greater than 1 in common. So I can't take out a number. There's no number that they share. However, they both have an a. So I have 2 a's right here, and I have 1 a right here. So I'm going to divide out of these the GCF of an a. I'm taking out an a from there, okay? And then I'm going to look over here, and I've got a positive 10a and a negative 90. So this 90, which if I do this correctly, that second term should never have a variable in common with that b because it's a constant up here. So they don't share a variable. However, when I think about 10 and negative 90, I do have a GCF of 10. So I'm going to divide out of those the 10. All right, so what is the GCF of the 2 binomials? This first binomial had an a in common. The second binomial had a 10 in common. So then the question is, when I divide out the GCF of each binomial, what remains? So I'm just going to rewrite it. So for this first one, I took out an a. So I'm going to put that out front because I divided it out. So then a squared divided by a is just a. And if you're unsure of how I did that, you need to go back and look at those Algebra 1 basic skills. Look at how exponent rules. That's what that basically is. All right, so then negative 9a divided by a is minus 9, because I took the a and I put it out front. And I can always check myself, what's a times a squared, what's a times negative 9, negative 9a. So I'm undoing all that multiplication we've practiced. All right, so then in the second binomial, what did I divide out? Well, I divided out a positive 10. And when I divide that out, what remains? Well, 10a divided by 10 is just 1a, or a. And then negative 90 divided by 10 is minus 9. Okay, so when I divide out of the GCF of each binomial, what remains? That's what remains. So now I hope that you're noticing that they both have an a minus 9. So do the binomials have anything in common? They do. They have an a minus 9. They both have that a minus 9. So I think my question's cut off, but the question that is cut off on the bottom asks me, when I divide that out, what remains? So when I take the a minus 9 that they both have in common out, what am I left with? I'm left with a plus 10. And that is the factored version of a squared plus a minus 90. And I can always check myself by taking this a and distributing it to a plus 10. So I'd have a squared plus 10a, and then distributing this negative 9, negative 9a minus 90. And then when I think about it, which I end up with essentially this, negative 9a plus 10a gives me that 1a. So really, if I go backwards, it's what we're familiar with, the distribution, but I end up with with the original problem. So you can always check yourself. All right, go ahead and kind of walk through those steps, think about it, and I'll do a few more examples, and then I'm going to let you do some practice. All right, so I'm going to go through that exact same process. I now have 5x squared minus 13x plus 6. So I'm going to start with that first question. What is A? What is B? What is C? So I know that A is 5. I know that B is negative 13. And I know that C is 6. So I'm looking for those ABCs. So then my next question is, what is A times C? So literally in my T-chart, I'm going to do 5 times 6, which is 30, and I'm looking for the B of negative 13. So what is A times C? And now I'm looking for what are the factors of A times C. So what are all the ways I can multiply two numbers together and get positive 30? Okay, well, I always like to start with 1, so 1 times 30. But I also know that another way I can get a positive number is I can multiply two negatives together. So negative 1 times negative 30. All right, then 2. 2 goes into 30. 2 times 15. But I could also have negative 2 times negative 15. All right, 3 goes in, so 3 times 10, or negative 3 times negative 10. And then I have 4. Can 4 go into 30? No, it can't, not evenly. And then 5 times 6, or negative 5 times negative 6. And then my next number after 5 would be 6, but I already have it accounted for, so I'm done. Those are all the factors of 30. So now I'm looking for what factors add to be that B value. So when I look at that, when I add them together, 1 plus 30 is 31. That's not it. I'm looking for negative 13. So negative 1 plus negative 30 is negative 31. That's not what I want. So when I think about I want to add it together and I want it to be negative, I don't want to look at the positive versions because any positive number plus another positive number is going to be positive. So I'm looking for the negative versions, and I see that negative 3 plus negative 10 gives me that negative 13. So I found the factors that I want to use, and they are negative 3 and negative 10. That gives me negative 13. All right, so then my next question is, how can I rewrite the trinomial with a busted B? So again, I'm going to take the A term, because I'm not busting the A, and I'm not busting the C, but I'm busting the B into the two numbers that still add to be negative 13x. So negative 3x plus 10x. And it does not matter what order you put it in. You could put negative or positive 10x minus 3x. That doesn't matter. You'll get the same answer. So if I were to simplify this, if I were to combine like terms, I just realized I wrote that wrong. That should be minus 10x, not plus. So if I were to, and that's why you always want to check yourself, is if I were to combine like terms, negative 3x minus 10x, I still get negative 13x. So I have rewritten it with a busted B. Okay, how can I group the two binomials? Remember, I told you it will always be the first two terms and the second two terms, but make sure that you include that sign with the first term. Okay, so I did that. What is the GCF of the two binomials? All right, so when I look at the first binomial, 5x squared minus 3x, they do not have a GCF. 5 and 3, there's no number other than 1 that can go into both of those, so there's no coefficient that they have in common. However, I do see that they both have an x, so I'm going to take out 1x. I'll wait for that. So then the second one, what is the GCF of these two binomials? And when I look at it, I'm looking at -10 and +6. Now, in the previous problem, this term was positive. We always want the first term of each binomial to be positive. So I notice that this is a -10. So whatever number I decide to take out, I need to take out the negative version because I need this to be a positive number. So when I look at 10 and 6, I see that they have a 2 in common. And so instead of just taking out the 2 that they have in common, I'm going to make it a -2. Again, because this is a negative value, the first term. I don't care about the second term, but the first term. So I'm going to divide out a -2 from both of those because that's what they share. All right, so when I divide out the GCF, what remains? So this first one, I took out an x. So 5x squared divided by x is just 5x. Minus 3x divided by x is -3. Okay, and then I take out a -2 from this. So -10x divided by -2 is 5x. And 6 divided by -2 is -3. And we notice that we are in luck because they share the 5x minus 3. So do the binomials have anything in common? Yes, they do. They share 5x minus 3. So when I divide that out, what remains? X minus 2. And that is my factored version of 5x squared minus 13x plus 6. All right, so if you're starting to catch the hang of it, you can go ahead and pause the video, try this problem, see how you do, and if you get it, you can move on to the homework. If you don't, I would encourage you can at least do these first 3 questions, maybe even the first 4. So every problem on your homework, I expect that you do at least the first 3 to 4 questions, because I know you know how to do that even if you get stuck. But I'd like you to go through, try it, see as far as you can go. Pause the video, see how far you can go, and then when you have an answer or when you get stuck, go ahead and watch how I do it. All right, so to solve this, I'm always starting with A, B, and C. So when I look at this, A is 1, B is -3, and C is -28. So the first question, what is A, what is B, what is C? All right, the second question, what is A times C? So 1 times -28 is -28. And then I always put my B value over here. All right, so it asks, what are the factors of A times C? So what are the factors of -28? Well, it's a negative number, so one is positive and one is negative, because a positive times a negative is the only way I can get a negative. So I always start with 1, so 1 times 28, but one of them has to be negative. Or I could have 1 times -28. All right. 2 goes into it. So 2, I'm going to do -2 times 14, or 2 times -14. I also have, the next number would be 3. So does 3 go into 28 evenly? No, it doesn't, because 28 divided by 3 gives me a decimal. 4 does go into 28, so it would be 4 times 7. -4 times 7, or 4 times -7. 5 doesn't go in, 6 doesn't go in, and then 7 we already have, so we're good. These are all the factors of -28. Now, if you start to get the hang of this and you don't have to write down all these factors, if you can see immediately what it is, don't worry about that. All right, so then the next question is, what are the factors that add to BB? So I'm looking for which one of those give me -3 when I add them together. Well, I know that -1 and 28, these are going to be too big. Even these are going to be too big. And I want it to be -3, so I'm going to choose 4 minus 7, which is -3. So those are the factors that I'm going to bust the B. So it's no longer going to be -3x, it's going to be 4x minus 7x, or -7x plus 4x. Either way works. So how can I rewrite the trinomial with a busted B? So I'm going to keep the a squared, because I don't bust the a, keep the c, because I don't bust the c, but I'm going to bust the b. So plus 4x minus 7x, and again, is 4x, minus 7x, is that negative 3x? It is. So if I were to simplify this, I've not changed the value of the expression. Like I said, you could have negative 7x and plus 4x here. All right. How can I group the two binomials? So always, 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 it's going to be grouped like that. And what is the GCF of the two binomials? So when I look at x squared and 4x, I see that they have an x in common. So x squared and 4x, I can take out that x. And what remains is x plus 4. Kind of going out of order here. Negative 7x and negative 28x. So I see that that first term is negative, so I need to take out whatever number it is, I need to take out a negative. And 7 and 28 share a negative 7. So I'm taking out a negative 7, and what remains is x plus 4. Because negative 7x divided by negative 7 is a positive 1x, and negative 28 divided by negative 7 is a plus 4. So when I look at that, my next question asks me, when I divide out the GCF of each binomial, what remains? So I did that. Do the binomials have anything in common? I see that they both have this x plus 4, which is what I want. So if I don't get that, then I did something wrong. And when I take that out, that leaves me with x minus 7. So that is my factored trinomial. I can always check myself by multiplying x out, 4 out, combining like terms, and I should end up with x squared minus 3x minus 28.